Yes, sir.
Okay. So last we discussed about the constant and also arithmetic operators. No? Then we also talk about this. Okay. So this screen is blurred, but I also explained the assignment operators to all of you. Now we will discuss about the arithmetic, sorry, comparison and logical operators. Comparison and logical operators. For program flow, the comparison as well as logical operators are required. They are grouped in three categories. So comparison and logical operators are mainly useful for the program flow. Okay. So comparison and logical operators are mainly grouped into three categories. One is relational operators, second one is equality operators, and third is a logical operators. Okay. So with and this all comparison and logical operators have the following symbols and their meanings are given. This is nothing but the less than, this is greater than, less than or equal to, greater than or equal to. This is called the equal to. If I wish to compare two variables, whether the x equal to y or not, so to compare the value of two variables or the identifiers, I have to use this equal to. This is for negation is means not, and when you write the equal to with that, it is called the not equal to. So these two are comparison operators. These are relational operators. And this is called logical and this A and D is in capital A and D. This is logical and this is symbol for the logical or and this is for the not. Okay, and these are said to be a logical operators. So comparison and logical operators are mainly classified into three groups. One is relational operators, second one is comparison operators, and third one is a logical operator. So we will see one by one these three. First, we talk about the relational operators. Relational operators compare values to see if they are equal or if one of them is greater than the other and so on. So relational operators are mainly useful to see whether they are less two variables are given to you, whether the one of the variable or the identifier value is less than the second, greater the second, less than or equal to, or greater than or equal to. It produces as a result, when you compare two variables using the relational operators, it produces as a result either 0 or 1. Okay, either 0 or 1, or sometimes you can say that either false or true. False means it is 0 and true means it is a 1. So either 0 or 1, or you can say either false or true. For example, if you are saying that if x is less than y, so whether this is either true or false. Okay, so that is how it is saying that when you compare two variables using the relational operators, as a result you will get the either true or false. The following operators are used to perform the relational operations of the two variables or expressions. So which are that? Less than, greater than, less than or equal to, and greater than or equal to. The syntax of relational operator is So as I say that it is useful to compare two expressions. So what is the syntax? So expression 1 and expression 2, and then some relational operators is used. The expression 1 will be compared with the expression 2, and depending upon the relational operator like greater than or less than, and the result will be either true or false. So expression 1 will be compared with the expression 2, okay, and depending on this operators, either you will get the result is either true or false. किसी को एडमिट होने में प्रॉब्लम नहीं है ना, सबको मिल रहा है ना एडमिशन? ओके, आगे बढ़ते हैं. For example, let us say I am comparing 3 with the 4. So whether the 3 is greater than 4, what is the result? If you are comparing 3 with the 4 and the operator is a relational operator which is of a greater than in nature, बोलिए. Am I audible?
Yes, sir.
तो रिजल्ट क्या आएगा?
False.
Yes, it is a false because 3 is less than 4. So result is a false. Whether 6 is less than or equal to 2, again it is a false.
False.
10 is greater than minus 32. Yes, 10 is greater than minus 32. The result is true. Now, if you are multiplying 23 with 7, okay, again you can see that if I wish to compare two expression, but because I have used the brackets, so it will perform the first this and then this. Okay, and you can also say that the first it will perform the bed mass and then logical. Okay, relationals, logicals, etc. So what is that? 23 plus 23 into 7, and what about this minus 67 plus 89? Of course this number is smaller than this, so this expression is greater than this, the result will be okay. So whenever, yes, hello, any query? Hello. Okay. So whenever you wish to use the logical operators or comparison operators or relational operators, you have to see that what kind of the expression would you like to evaluate and then compare. So always as and when if required, use the brackets to avoid the confusion. Now these are all about the relational operators. In the same line, you can have equality operators. The following operators are used to check the equality of the given expression or a statement. These operators are double equal to and not equal to. That is the negation equal to. It is called not equal to. Not that single equal to sign is considered as an assignment operator. I told you if you are using only single equal to sign, the computer will understand that you are using the assignment operator. It is not a equality operators or comparison operators. Okay, anyhow. Like the relational operators, the equality operators produce the result either true or false. Similar to relational operators, equality operators are also having the result either true or false depending upon the condition used in the program. So let us understand with the following examples. Here a equal to 4 given, b equal to 6 and c equal to 3. Now it is saying that whether a equal to b, so here a equal to 4, b equal to c. So we cannot say that a equal to b, so the result is false. Now a into b not equal to c. So a is 4, b is 6, 4 6 are 24, 24 not equal to 3. So that is correct. So that is how the result is true. Now if I am comparing the two character constant, so both characters are different. So that means their result is false. If you are saying that y equal to y, then the result will be true. So that is the use of a equality operator. Now we talk about the logical operators. So of course, what are the logical operators? Mainly you can use the logical operators at the logical AND and logical OR are lower in precedence than the relational operators, which in turns are lower than the addition and subtraction. It means that if you have the three operators, one is logical, second is relational, and third one is arithmetic. So compiler, which has the among the three, which has the highest precedent? So this has the highest precedent. That means arithmetic operators are performed first, then relational operators, and then the logical operators. That means logical operator has the lower precedence than the relational operators, and relational operator has the lower precedence the arithmetic operators. Okay. So, but it is advisable to use, and again, if you are talking about, if you have given these two logical operator, logical and logical or, so which has the highest precedent? So it is saying that logical and has the highest precedent than the logical or. So that is what it is saying, that the operator logical and has higher in precedence than the operator logical or, but it is advisable to use parenthesis as and when required. So this is logical and, this is logical or, and this is not. Not is nothing but it is a unary operator. And unary operator has the highest precedence. Okay, so we will come to that unary operator. I will tell you. Logical and, a compound expression is true when two conditions or expression are true. So when you say that the resultant expression is true, so when the expression 1 and expression 2 are true, then if you use the logical AND as a logical operators, then the result will be true. To write both condition, the operator's logical AND is used in the following way. So general syntax of the using the logical AND, that expression 1, then logical AND, that is the logical operators, and then expression 2. In the two expressions, the conjunction must be integer. That means expression 1 and expression 2, that must be integer. The floating point number is not allowed. The character data are converted into integer and are then allowed in the expressions. Okay. If your data is a character, it may be converted into the integers, and then you can use the logical AND. So following situations are given. Suppose expression 1 is true, expression 2 is true. Then what happens? If both expressions are true, result is a true. If expression 1 is true, but expression 2 is false, and then your logical AND, then the result is a false. If expression 1 is false, expression 2 is true, result is false. And if both are false, result is false. So if you remember, in a set theory, we have used the concept of intersection. When you say that you will have the certain element in the intersection B, if that elements are in A as well as in the B, then of course it is over intersection B. Suppose if none of the elements are common in the A intersection B, then it is giving the phi. So here it is saying that if the result 1, expression 1 and expression both are true, then and only the result is true. If any one of the expression is false, result is a false. Okay, it's a simple logic. So let us understand the following example. Let us A equal to 4, B equal to 5, and C equal to 6. Now I wish to evaluate this expression. I have written in the bracket A less than B, then logical AND, and then B less than C. So what happened? 4, A is equal to 4, B equal to 5, and B equal to 5, and C equal to 6. So I am writing that. Now I am because it will first operate the bracket. So what happened? Whether the 4 is less than 5? Yes, 4 is less than 5. The result is true. Whether the 5 is less than 6? Yes, result is true. And because of the both expression are true, the final result is also true in a logical AND. Then the result of this expression is true. Okay. Up to here clear? Am I audible?
Yes, sir.
Yes.
ठीक है, सुनाई दे रहा है लेकिन आप जवाब नहीं दे रहे हैं. Okay. Now we talk about the logical OR. So similar to logical AND, logical OR, which has the following form or the syntax: expression 1, then you can have the syntax of logical OR, and then expression 2. And it equals to true if either expression 1 or expression 2 is true. So we talk about A in union B. If A has the some element, B has the element, the result will be both combination of element. That means if the expression 1 is true or expression 2 is true or both are true, the result is a true. That means if both are false, then and only then the result is false. So we have situation: expression 1 is true, expression 2 is true, and if we are using the logical OR, the result is a true. If expression 1 is true, expression 2 is false, but either of the result is true, the expression is result is true. Expression 1 is false, expression 2 is true, but either of the expression is true, the result is true. And both expression are false, result is false. So this is the example. If A is less than B, B is greater than C, A is 4, B is 5, so 4 is less than 5, the result is true. 5 is greater than 6, no, the result is false, but the result, overall result is true. Why? Because we are using the logical OR. In logical OR, what happens? Any one of the either of expression is true, result is true. Okay. Now third, so we have seen two, logical and logical OR. Now we will talk about the logic negation. That is called logical negation operator. The result of the logical negation operator is, you can see that here we do not require two expression, only one expression is required. Okay. What is the negation of true? It is false. What is the negation of false? It is a true. The general form of the expression of logical negation is logical negation operator and then expression. So it is a, because you require only one expression to evaluate. Therefore, this is nothing but unary operator. Okay. Depending on the condition of the expression, that is whether it is true or false, it will complement the result. Suppose some expressions we evaluated and the result is true, but when you give the negation, it will complement it. What is the complement of true? It is false. If the expression is false, so what is the complement of false? It is a true. For example, you have written negation A less than B or C less than B. So 4 less than 5, yes, it is true. But what is the negation of true? It is a false. 6 is greater than 5, yes, it is a true. And if any one of the expression is true, result is a true. But suppose if you wish to evaluate, instead of this, you wish to evaluate in this way. Okay. We forgot to write a what? We forgot to write bracket. So First it will evaluate this, then it will evaluate this, and then it will evaluate this particular bracket. Okay. So this is true. 6 is greater than 5, it is true. The result is true, but negation of true is false. So if your small mistake of using the bracket will change entire results. So that is how we have to be very careful while using the bracket. The negation operator has the highest level of the precedence than the logical and logical or. So which operation execute first? First it will execute among the logical operator. First it will execute negation. Second it will execute the logical and third it will execute logical or. Parentheses are usually necessary to reduce unwanted and unexpected results. Since logical AND has higher precedence over the logical OR, care should be taken to use parentheses whenever required. So as I told you that logical AND has the highest precedence than the logical OR. So first it will execute this, second it will execute this, and third it will execute this. So let us understand. If I have this expression 1, then logical OR, expression 2, the logical AND, and expression 3, logical OR, expression 4. Then computer evaluate it. So which has the highest precision, whether logical AND or logical OR? इसका ज्यादा प्रेसिडेंस है, पहला कौन सा evaluate होगा? So logical AND has the highest precedence. That means this bracket will evaluate first, this particular. So expression 1, logical OR, then this evaluation. Why I have given the bracket? Because to just show you that it has the highest precedence. And then expression 2. Suppose we wish to evaluate this way. Okay. We wish to evaluate this way. बट आपने ब्रैकेट नहीं दिया तो क्या हुआ, इसने पहले इसको एवेल्यूएट किया, बाद में इसको एवेल्यूएट किया. ठीक है. So we have to be very careful, cautious while using the brackets. So for example, this is example. Let us A less than B, then logical OR, B greater than C, logical AND, this and this. So what is the A is 4, B is 5, and C is 6. Now 4 is less than 5, true. 5 is greater than 6, false. 4 is greater than 5, false. And 5 is greater than 6, false. Now this is the result with you. What, which has the highest precedent? The logical AND has. That means it will first execute this. So what is the, if both are false, that means result is false. The true, either it will execute with this or either it will execute this. So you can take any one. Let us say if I am taking the true and false, what is the result? It is a true, and false is false, and true and false result is true. But if I am using, because I wish to evaluate in this way, then first it will perform the brackets. This is true, this is false, the result is true. This is true, sorry, this is false, this is false, the result is false. And then true, logical AND false. Okay, because the bracket has the highest of precedent, that means whatever is there in the bracket it will execute first. So true, logical and false, the result is false. Here you can see the result is true, and here it is a false. So that means if you avoid the bracket, if you wish to evaluate this way, then you should always use the brackets. Why? Because the certain operators has the higher precedence over the certain operators. So logical AND has the higher precedence over the logical OR. Any questions up to this comparison and logical operators? Anyone?
No, sir.
Okay. That whatever we discuss, they are all said to be a comparison and logical operators. Now we will talk about the bitwise logical operators. Bitwise, that means they are talking about the binary pattern 0 and 1. Okay. There are certain situations wherein bitwise operations are to be performed, and this is possible in a C++. Normally, most of the high-level language does not support the bitwise operations. The bitwise operators are one of the salient feature of C++. The following operators are nothing but the bitwise operators. कौन इतना लेट धीरे धीरे आ रहा है? ठीक है. So bitwise operators are the salient feature of C++. What are the bitwise operators? So this is the single ampersand sign, then cap, then this, then right shift, left shift, and complement. So this is called bitwise AND. This is a bitwise exclusive OR. This is a bitwise inclusive OR. Bitwise right shift, bitwise left shift, and bitwise complement. So we will see one by one what is the role of the bitwise AND, bitwise exclusive OR, inclusive OR, bitwise right shift, bitwise left shift, and bitwise complement. So let us start with the bitwise complement. The complement operators switches all the bits in binary pattern. That is, all the zeros become ones and all the ones become the zeros. So whenever you have some binary patterns, let us say 0, 1, 0, 0. And if you write the complement of this, what is the result? Wherever the 0, it is 1. 1, 0, 1, 1. So complement means wherever you observe the 0 in the binary patterns, it will complement each other. That means 0 is replaced by the 1. The complement of pattern is often useful in signaling and controlling other devices where the several different signals may be complementary of each other. So especially physics and electronics uh, device are usually using this particular bitwise complement operators. So let us, here I have given the variable x whose value is 23. I wish to convert this 23 into the binary pattern. How to convert? So 2 11s are 22, 1 is remainder, then 2 5s are 10, 1 is remainder, 2 2s are 4, 1 is remainder, and 2 1s are, this is 0. That means your 2 1s are 2. That means your pattern is, इसकी जरूरत नहीं, हम सिर्फ ये 2 ही रखते हैं. So your pattern is this. What is that pattern? It is a 1 0 1 1 1. But usually we are writing the bits of a 4 in a group, and usually we make the patterns in a 8 bits. So what we do, there are here in the second group it is a 1. So what I will do to make it of a 4, I will add the 0 0 0. So this is my answer of a 23. That is what written here. Okay. Now what is the complement of x? Complement of x is that wherever the 0, you have to write the 1. So here it is 0, so I am writing 1. Here 0, 1, 0, 0 to 0, why 0? Why 0? Any mistake? A mistake is there, is it? It's 3 0, 0 1, 1 0, and this is a 0. Then it should be a 1. Okay. So what is the complement of this? It is a 1 1 1 0 1 0 0 0. And what is the answer of this? So this is 0 2 raised to 0. This is 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7. Okay. Have I made any mistake? Let us see, verify. So what is that 0 into 2 raised to 0? It is 0. Then 0 into 2 raised to 1, it is 0. 0 into 2 raised to 2 is 0. 1 into 2 raised to 3 is 8. Okay, 1 into 2 raised to 3 is 8. 8 into 1, that is 8. 0 into this is 0. 1 into 2 raised to 5 is 32. This is 1 into 2 raised to 6 is 64, and this is 128. So this is a 128 plus 60 plus 32 and plus 8. What is the result? It is 8, 1, 2, 3, 6, 9, 3, 12, plus 1. It is a 228. This is not 32, it is a 228 because I have made the mistake here. Okay. So similarly, let us understand the, as the bits are always group of 4, that is what I said. If I have given x equal to 5, so I am taking that 2 2s are 4. Okay. Then what is the result? What is the result? Remainder 5 minus 4 is 1. Then 2 ones are 2. That means remainder is 0. So this is nothing but 1 0 1. So 1 0 1, if you wish to complete the bit, what is that? You have to add the, this is 1 0 1. You have to add the 0. So it is now of a 4. Okay. And because of this 4, if you make the complement of this, it is what written here. 1 into 2 raised to 0, 0 into 2 raised to 1, 1 into 2 raised to 2, and 0 into 2 raised to 3. What is the result? 1 plus 4, that is the 5. So this is the 5, so that is true. Okay. Here it is a, what is that? Complement of this is nothing, wherever the 0 you write the 1. 1 is 0, 0 है तो वहाँ 1 लिखो, 1 is 0. तो इसका क्या आएगा? 0 into 2 raised to 0, 1 into 2 raised to 1, 0 into 2 raised to 2, and 1 into 2 raised to 3. So 0 into 2 raised to 0 is 0 into 1, that is 0. 1 into 2 raised to 1 is 2, the 1 into 2 is 2. And 0 into 2 raised to 2, that 0 into 4 is 0. And 1 into 2 raised to 3 is 8. So that is the 2 plus 8 is 10. Okay. So if you get the sum patterns instead of the 4, you will get some 5, then you have to make the complete of 4. That is how I have added the 3. And then this is the complete bit pattern. Okay. If it is of a 4, then there is no need to add the 0 0 0. Now we first, that is all about the complement operators. So what we do, I have just converted this particular decimal system 23 into the binary system. ओके तो डेसिमल को बाइनरी में कन्वर्ट कैसे करना है वैसे, और बाइनरी को डेसिमल में कन्वर्ट कैसे करना है तो ऐसे, यहाँ पे आएगा 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. Why 2 raised to 3? Because there are 4. So 4 minus 1 is 3. Is that clear? Hello.
Yes, sir.
Any doubts up to here? Anyone?
No, sir.
It's very simple, no? Okay. Now we talk about the shift operations. So shift operations, as I say that there are left shift and there is a right shift. The shift operations take binary patterns and shift the bits of the left or right and keeping the same number of bits by dropping shifted bits off and end the filling with the 0 from the other end. It means that suppose if I'm saying that this is my bit pattern, if I'm shifting this from the left, it means I will drop the left hand side figures. So what is that? It is the 0. So I have dropped. And right hand side what happened? I will add the 0. Why 0? Every time whatever the left hand side numbers I have to drop, and right hand side I have to add the 0. So you can see that this is the left shift operator is used for the left shifting, x equal to 33. So by using this binary patterns you can have, or you can convert your decimal patterns into the binary patterns, you will get this. Now x left shift 1, it means the bit pattern of x value is left shifted by 1s. तो दैट मीन्स इट इज शिफ्टेड बाय वंस। तो वंस मीन्स इसका मतलब है लेफ्ट हैंड साइड से आप जो भी नंबर से 0 1 उसको आप ड्रॉप करेंगे, और राइट हैंड साइड में क्या करेंगे, यू विल ऐड द 0। तो हियर आपके पास कितने थे, 0 2 थे, अब यहाँ पे देखो एक ही है। ओके, यहाँ पे क्या था, 1 पे ही था, लेकिन 1 के बाद यहाँ पे क्या लगा है, 0। पैटर्न आपकी 8 की ही रहेगी। लेफ्ट साइड से आप ड्रॉप करेंगे, राइट साइड से आप 0 फिल करेंगे। तो ये आपका रिजल्ट हुआ एक्स लेफ्ट शिफ्ट 1। अब यहाँ पे जब आप लेफ्ट शिफ्ट 3 करेंगे तो इसका मतलब क्या हुआ, 3 बार आप लेफ्ट हैंड साइड के नंबर ड्रॉप करेंगे। तो यहाँ पे आपके कितने थे, पहली बार में हमने इसको 1 ड्रॉप किया, राइट हैंड साइड पे 0 ऐड किया। दूसरी बार कौन सा नंबर है, 0 है, तो दैट विल बी ड्रॉप। अब क्या बचा, 1 1 0 0 0 1 0 एक 0 ऐड करो। और फिर आप क्या करेंगे, तीसरी बार लेफ्ट शिफ्ट करेंगे तो ये नंबर आप ड्रॉप करेंगे। तो क्या बचा, 0 0 0 0, तो यहाँ 4 0 है, बाद में 1 0 0, दो तो थे। अभी आपको क्या करना है, राइट साइड से फिल करना है, क्यों, क्योंकि आपको इसको कन्वर्ट करना है 8 में। तो दिस इज द रिजल्ट पैटर्न। एंड रिजल्ट पैटर्न का आंसर क्या आएगा, 2 raised to 0 2 raised to 1, that means 0 into 2 raised to 0 plus 0 into 2 raised to 1 plus 0 into 2 raised to 2 plus 1 into 2 raised to 3 plus 0 into 2 raised to 4 plus 0 into 2 raised to 5 plus 0 into 2 raised to 6 plus 0 into 2 raised to 7. Why? Because there are 8. So you can see the last 4 0. ये शुरू ऐसे होता है, 2 रेस टू 0 0 इंटू 2 रेस टू 0 0 इंटू 2 रेस टू 1 0 इंटू 2 रेस टू 2 1 इंटू 2 रेस टू 3 4 5 6 एंड 7। तो 1 कहाँ पे, सिर्फ एक ही जगह पे, बाकी सब जगह पे क्या है, 0। तो रिजल्ट इज 0 प्लस 0 प्लस 0 प्लस 8 प्लस 0 0 0, तो रिजल्ट इज 8। तो व्हाट इज द रिजल्ट ऑफ दिस, it is a answer is 8. Earlier it was a x30, it was a 33, now it become the 8। राइट शिफ्ट में क्या करेंगे, बीट को आप क्या करेंगे, राइट से ड्रॉप करेंगे, एंड लेफ्ट में आप क्या करेंगे, 0 ऐड करेंगे। देखो y इक्वल टू 41 है, उसकी बीट पैटर्न ये है, और मैंने कहा कि जस्ट y को राइट शिफ्ट करो 3 टाइम्स। तो मैंने क्या किया, राइट साइड से इसको ड्रॉप किया, लेफ्ट साइड से 0 ऐड किया, फिर यहाँ दूसरी बार में क्या किया, ये 0 यहाँ पे ड्रॉप किया, ये 2 थे तो अभी कितने हो गए, 1, लेफ्ट साइड से मैंने एक और 0 ऐड किया, अब यहाँ पे और एक 0 ड्रॉप किया, तो अभी लास्ट में क्या बचा, 1, और यहाँ पे मैंने एक और 0 ऐड किया, तो टोटल कितने रहे ये। एंड व्हाट इज द रिजल्ट ऑफ दिस, 1 into 2 raised to 0, that is 1, 0 into 2 raised to 1 is 0, then 1 into 2 raised to 2 is 4, that is the 5। तो रिजल्ट ऑफ दिस इज 5, और वो हमने आगे निकाला था, अगर आपको याद है तो 5 को कन्वर्ट किया था, है ये 0 1 0 1, और यही है लास्ट में 0 1 0 1, बिकॉज ये 0 तो 0 है, उसके साथ कुछ भी मल्टीप्लाई करो रिजल्ट विल बी 0। इज दैट क्लियर?
यस सर।
यस सर।
तो हमने अब तक देखा बिटवाइज कॉम्प्लीमेंट, देन वी टॉक अबाउट द bitwise shift operator, bitwise left shift and bitwise the right shift. Now we talk about the bitwise logical operators. So bitwise logical has 3 logical operators are different. What are the logical? They are logical and, logical or, and negation. But when I am saying that bitwise logical operators, that means bitwise logical and, bitwise logical or, and bitwise, that is inclusive or, and this is bitwise logical exclusive or. So let us understand the bitwise AND. The bitwise AND operation will be carried out between the 2 bit patterns of operands. So let us say variable x and y is given. Value of x is 5, value of y is 2. If I am converting into the bit patterns, this is that. So what is the bitwise logical AND? You can see here it is 0, here it is 0, then it is 0, then the result is 0. Here it is a 1, result, and here it is 0, the result is 0. Here it is 0, इट इज a 1, रिजल्ट इज 0, 1 0 this. इसका अर्थ ये हुआ बिटवाइज लॉजिकल एंड क्या कहता है, इफ बोथ आर 1 देन, दूसरा एग्जांपल देखते हैं, ए एंड बी 6 एंड 3, यहाँ पे 0 है, यहाँ पे 0 है, रिजल्ट इज 0, यहाँ पे 1 है, यहाँ 0 है, तो रिजल्ट इज 0, 1 है तो रिजल्ट इज 1 एंड 0 1, तो इसका मतलब इफ both expression bit pattern has the 1, the result is 1. If any one of the expression has the result 0, the result is 0. 1 0 है तो भी क्या आएगा, 0 आएगा, 0 0 है तो भी क्या आएगा, 0 आएगा. So wherever the both expression patterns are 1 1, the result is 1. So that is how. And you can convert it. It is the 2 raised to 0 and 2 raised to 1. The result is 2. यहाँ पे कितना है, 3 क्यों है, क्योंकि 1 into 2 raised to 0, that is 1, and 1 into 2 raised to 1, that is 2. 1 plus 2 is 3. Okay. और दूसरा मटेरियल दूसरे में क्या, similarly if I am talking about the bitwise, आपको जो सेकंड पीडीएफ भेजा है उसमें जो है उसकी बात कर रहे हैं. तो मैं इसको अपलोड करता हूँ, है नहीं, तब तक आप देखिए, कोई क्वेश्चन है तो बताइए. आई विल जस्ट अपलोड इनटू द वन नोट. एनी क्वेश्चंस, एनीवन?
सर मुझे वो राइट शिफ्ट और लेफ्ट शिफ्ट में सर पता नहीं चला.
जैसे लेफ्ट शिफ्ट में क्या है, जब आप लेफ्ट 1 करते हैं, एक्स लेफ्ट 1, इसका मतलब आपकी पैटर्न्स में जैसे मैंने लिखा 0 0 1 0 1 1 1 1 8 का रहता है, तो मैं क्या करूँगा, लेफ्ट शिफ्ट है तो ये इसको ड्रॉप करूँगा लेफ्ट साइड से, एंड राइट साइड से मैं क्या करूँगा, 0 ऐड करूँगा. तो व्हाट इज द रिजल्टेंट पैटर्न, इट इज 0 1 0 1 1 1 1 एंड 0. तो ये 4 का एक हो गया, ये 4 का. राइट शिफ्ट है तो मैं क्या करूँगा, इफ इट इज फ्रॉम राइट शिफ्ट तो मुझे राइट साइड से मुझे उसको ड्रॉप करना है, ठीक है, एंड
वन
लेफ्ट साइड,
ड्रॉप हो जाएगा
हाँ 1 ड्रॉप होगा एंड
और 0 ऐड होगा लेफ्ट साइड
हाँ
में.
या 0 ऐड होगा. तो रिजल्टेंट पैटर्न विल बी 0 0 0 1 0 1 1 1. तो ये 4 का है, ये 4 का, ठीक है. दिस विल बी ड्रॉप, ठीक है.
तो सर वो ऊपर सर 32 में 5 का ग्रुप बनाया हुआ था.
5 का कहाँ है, 8 का बनाया ना.
32 में सर, उसके भी ऊपर
33 में
32 का था सर.
ये इसकी
सर
बात कर रहे हैं,
वहाँ
32 कहाँ लिखा हमने, 23 है ना, 23 को कन्वर्ट किया ना.
उसके नीचे था सर थोड़ा.
बताइए कहाँ पे, यहाँ पे 5 का आ रहा था, जैसे 23 को आप कर रहे हैं ना, तो ये 5 का आता था, लेकिन 5 का तो होता नहीं, इधर 4 का होता है या 8 का होता है, तो ये 4 का है, तो ये एक बचा, तो मैंने क्या किया, आगे 3 0 ऐड किए, तो उसको 8 का बनाया, ठीक है.
जी सर.
एनी मोर क्वेश्चंस, एनीवन? नो क्वेश्चंस?
No, sir.
अच्छा है, सभी होशियार हो, क्योंकि मेरे को ढूंढने में टाइम लगता है तब तक तो। व्हाट्सअप। ठीक है, मैं सीधा इसमें से, क्योंकि उसको मुझे टाइम लगेगा ढूंढने में, व्हाट आई विल डायरेक्टली एक्सप्लेन यू फ्रॉम हियर। ओके, तो अभी बात कर रहे थे बिट वाइज और। बिट वाइज और में दो है, लॉजिकल एक्सक्लूसिव और एंड इंक्लूसिव और। ठीक है, तो इसको इंक्लूसिव और भी कहते हैं, और सिंपली इट इज ऑल्सो नोन एज ए बिट वाइज और। तो उसमें भी रिजल्ट क्या आएगा? 1 0 ही आएगा। ठीक है, लेकिन उसमें क्या था, अगर कहीं पे भी बिट वाइज एंड में कि 0 है तो रिजल्ट 0 है, लेकिन यहाँ पे क्या होगा, कहीं पे भी रिजल्ट 1 है, रिजल्ट विल बी 1। फॉर एग्जाम्पल, वी हैव x and value is 5 and the binary pattern is 0 1 0 1, and y has the value 2 and the pattern corresponding is 0 0 1 0. If I find the bitwise or inclusive or, what is the result? It is a 1 0, तो कहीं पे भी 1 है तो रिजल्ट इज 1, ये भी 1 और ये भी 1 और ये आएगा 0। तो 1 into 2 raised to 0, that is 1, 1 into 2 raised to 2, that is 2, so 1 plus 2 is 3, and 1 into 2 raised to 2 is 4, so 1 plus 2 plus 4 is 7, so result is 7। ठीक है, तो दैट इज कॉल्ड बिटवाइज एक्सक्लूसिव और। लेकिन जब मैं बिटवाइज एक्सक्लूसिव और कहता हूं, ठीक है, तो उसमें क्या रहेगा, let us say x y 5 2, bit pattern here is 0 0 1 0, and here it is a 0 1 0 1। तो bitwise एक्सक्लूसिव और क्या करेगा, जहां एक जगह पे 0 है वहां पे क्या करेगा, एक जगह पे 1 है वहां पे 1 देगा। ठीक है, तो इसका रिजल्ट क्या आएगा, इसका भी आएगा 7। लेकिन अगर मैंने x ऐसा दिया है 6 3, what is 6? It is a 0 1 1 1, and 3 means it is a 0 0 1 1, and the result will be, यहाँ दो जगह 1 है तो एक्सक्लूसिव और में क्या हो जाएगा, वो ये बराबर है, ये 7 हो गया, ये 6 हो गया, 2 and 4। ओके, तो क्या करेगा, जहाँ 0 जहाँ दोनों में से 1 है वहां पे 1 देगा, लेकिन दोनों जगह पे 1 है तो उसको क्या करेगा, 0 करेगा। दोनों जगह 0 है तो उसको 0। तो एक्सक्लूसिव में, इंक्लूसिव में क्या है, वेर एवर द 1 द रिजल्ट इज 1। अगर दोनों में भी 1 है तो रिजल्ट 1 आएगा, किसी एक में भी 1 है पैटर्न में तो रिजल्ट 1 आएगा। लेकिन एक्सक्लूसिव में क्या है, किसी एक में 1 है तो रिजल्ट इज 1, बट अगर वो दोनों में 1 आया तो रिजल्ट इज 0। एंड व्हाट इज द आंसर ऑफ दिस, what is answer, 2 raised to 0 into 1, that is 1, and this 2 raised to 1 and this is 2 raised to 2, that is the answer is 5, 1 into 2 raised to 2। अब इसका ही मैं अगर एक्सक्लूसिव और निकालूंगा, सॉरी इंक्लूसिव और, what is the result, it is 1, it is 1, it is 1 and it is 0, क्योंकि कहीं पे भी 1 है रिजल्ट इज 1, यहाँ दोनों में 1 है तो भी रिजल्ट इज 1। what is the answer, 2 raised to 0 is 1, 2 raised to 2 is 1 is 2, and 2 raised to, that is the result is 7। ओके, एक्सक्लूसिव और में उसका रिजल्ट क्या आएगा, 7 आएगा। इंक्लूसिव और में एंड एक्सक्लूसिव में क्या आएगा, 5 आएगा। ठीक है, एनी क्वेश्चंस, एनीवन? Any questions, anyone?
ना सर।
तो आज के लिए हम इतना रखेंगे।
ओके सर।
तो अटेंडेंस कौन ले रहा है? तो दोनों जो अटेंडेंस है वो लेके मुझे एक्सेल शीट में भेज दीजिएगा। कोई
राजेंद्र।
नया नया एडिशन आया है? एनीवन न्यू एडिशन?
नहीं सर।
ओके, तो I'll stop